Okay, today we have Audi A3 1.8 Limousine 2014, and the engine management light is illuminating, and let's scan the car and see what the problem is and what diagnostic triple code is stored. The car has come from another garage, which is contractor of AA, roadside assistance recovery organization. So let's scan the car. So we have scanned the car, and we found two DTCs. One is for coolant pump control circuit open, the other is for engine coolant bypass valve control circuit open. So P260000, P268100. So I'm going to investigate this two fault codes, because in spite of that we cleared the fault code, but the fault code have returned back. So today we are going to investigate the fault code for Audi A3 Lemousine 1.8 TFSI 2014. So these are the fault codes which are stored in the memory. So ignore this one, because I have created this one while I was removing the turbocharged boost air pipe. So we are going to investigate this this one, and the other one, this P260000 and P268100. So, and this is the pump which the code is related to it. So let me bring that down or up. So this is the pump, and it says exploded view electric coolant pump. So actually together with the N82, this is called electric coolant pump, but the coolant pump itself is called continued coolant circulation pump, V51, and this together they are electric coolant pump, but individual, this one is called N82, this one, and this one is called V51. And okay, this is the supply voltage to V51. This is the supply voltage. If we follow this, and click here, and that straight away goes to this fuse, and it's 87A. This is supplied by 87A from the relay. So this one is supplied by a relay which cannot be shown in the illustration here. So if we go back, so 1 second. And that is here. Computer. So this, the 12 volts power is supplied by this wire to this other actuator as well, and also to this V51 or the continued coolant circulation pump. This one, continued coolant, and this one is connected to pin 87A at the relay engine pre-wiring harness. This is the wiring diagram for this. Wiring diagram is taken from 1.4 same age vehicle. Unfortunately, the wiring diagram on O2 data in UK is not available exactly for the vehicle itself. So its own wiring diagram for this pump. So this is the pump. It has 3 wires. So the power is supplied by fuse, and pin 1 is connected to the ground side of the circuit. If you can follow, that has come down here to the ground side, and this is the control wire. But you might see the color might be different when I'm testing on the vehicle. So but the concept and the principle is the same. So this is the control wire of the electric coolant pump, and this is the ground wire, pin 1, and the pin 2 is the power supply to the pump. And also there is no any manufacturer specification is available. I'm going to take the value of this while the ignition is on and the engine is off and the engine is completely cold. So right now it's morning here in the UK, and it's about approximately 11 o'clock, and the ambient temperature is about 11 degrees of Celsius. So now first I'm going to take the value of this control wire while the engine is off and the ignition is on, and then I'm going to start and watch the oscilloscope whether that is changing or not changing, and also see how when I yesterday tested the with the voltmeter. So the ground side was with the component connected together. So the wiring connector was connected to the pump. It had the ground side had 0.035 volts, and the control wire had a value of voltage 0.251, and the pin 2 or the power supply side had 12 volt or source voltage. Yes, now I'm going to because yesterday the engine was warmed up, and today the engine is completely cold, and I'm going to check that with you. Okay, this is the live data value that currently I am receiving through the scanner, as you can see here. So the coolant temperature is 51.8 Fahrenheit. Coolant, I'm not sure this one, which pump is that. That might be the one which might be this one, or might be the other one, because there are another main coolant pump which is driven by the belt, also installed on the vehicle, but I'm not sure. So the coolant circulation pump activation is 10% here. Coolant temperature is 3.83 for the voltages. Coolant temperature at the engine outlet condition like this, temperature sensor. So this is the value, and also it says the coolant shut off valve is closed. I think that's going to be this one. That's going to be this one, I think, because it says second you need to do that's going to be this one, coolant shut off valve. So right now it's closed. So this is the live data I'm receiving. Now I'm going to go underneath of the vehicle and connect scoop meter to the pump control wire and take value and see what valve we have. Okay, as you can see, we have come underneath of the car. So this one, this is red and white. This is the signal wire connected to the PCM or ECU. The middle one, which is this red one, this is the power supply, source voltage or 12 volt or battery voltage. So the brown one, which is this one, let me show you. This is the brown, this one, this is the ground side of the pump. This is the pump. And also one thing I should have mentioned before, this pump and the main pump both have been replaced by another garage. So the other garage has replaced both pumps and the fault code is still there. So they have replaced this and the main as well. So once again, this is the signal wire or the control wire connected to the ECU and to the pump here at connector at pin 3 of pin 3 at the connector. So the middle one is, this is pin 2, this is the red one, this is the power supply, this one, and the one which is this one here, or brown colored wire, is the ground side of the circuit. So the signal wire is connected to a blue probe, blue colored probe, back probe, and the middle one is connected to a red back probe lead, and the earth or the ground is connected to a black back probe lead. So leads are here, as you can see, leads are here, 3 of them. Now I'm going to connect the scanner and take the value. So the ignition is still on and the engine is off, and let me show you the temperature again, that I haven't started the car yet. So this is first morning here. I have started diagnosing the circuit. So this is the ambient temperature. It's approximately 11, because it's going to be 11 or 12. Okay, as you can see, let me zoom out the camera. As you can see, I have connected the first channel or yellow channel lead to the control wire of the pump, and connected the black lead of the scope to a ground. So we have got the, I think when I see the signal, I think this is controlled by the poles with modulation function or theory. So as I can see here, the on time is very less, and so this is the control wire value that I'm taking to. So now I'm going to move the lead to the power supply side. So I have camera in one hand. So now I have connected the power supply wire to the scope, and it reads 0. So let me I'm going to pause the camera once, and I'm going to, if the leads has, or the back probe has pulled back from the connector, I'm going to push a little bit back in. Okay, as you can see, the voltage is 0. So right now at the moment we don't have supply voltage to the pump. So I'm going to check that with the voltmeter as well, so to make sure that we have checked properly the wire. As you can see, we have no power supply to the pump while the connector is connected to the pump. And also, as you can see here on the scope meter as well, the scope meter reads 0 as well. So now I'm going to disconnect the connector from the pump and read the value. Okay, before I disconnect the connector from the pump, I'm going to check the ground wire as well with you. And now I am going to connect the scope meter to the ground wire, and see I have connected the scope wire, the scope lead, sorry, wire, not wire, the scope lead to the ground wire. As you can see, it reads 0. So now I'm going to disconnect the connector from the pump and take the value while the connector is disconnected from the pump. Okay, now I have disconnected connector from the pump, and the scope lead is on the power supply, which should be 12 volts, and I have this type of signal. Just the signal is fluctuating from 0 to 2.5 volts, so 2.5 volts to 0. Let me freeze this and see. So cursor 1 2.5 volt and cursor 2, so the bottom side of the peak to peak is 2.5 and 0.02 volts. So when I read the value with the digital voltmeter, so So it gives me just 0 values. And this is I have connected the digital voltmeter as well, and I'm taking the value of the wire by digital voltmeter as well, and it gives me 0. But here it's from peak to peak 2.5. Now I'm going to investigate or trace the power supply wire to the pump, and check whether the fuse is blown off, or whether the problem is with the relay or something like that, and then we'll share with you. Because yesterday when I checked off the camera, I did have a 12 volt at the pin number 2 at the connector, so power supply I did have 12 volts, so possibly that could be the relay stuck, closed or open, and or could be a blown fuse. Okay, this is the fuse box, and as you can see, fuse 9 is for the, let me show you. So this is fuse 9 on the fuse holder B9. Okay, and this fuse is responsible, as you can see, for this one as well here. For the pump, it's continued coolant circulation pump. It also, the fuse also supplies power to the pump as well, and to the rest of the components as well. So now I'm going to check this fuse 9 on the engine bay. So as you can see here, continued coolant circulation pump V51. So this is the fuse box, and I'm going to remove it. I'm going to check one by one. As you can see, this fuse is blown up, and that is going to be fuse number 9. See, so I'm going to replace this fuse, and then see if the 12 volt voltage can we have at the connector. Okay, I have replaced the fuse, and now I'm going to take measurement of the supply voltage. As you can see, I'm attaching this one here. This one is no good. And as you can see, I have got battery voltage. This is red probe connected to the power supply to the pump. Okay, let me check with the scanner as well. So okay, as you can see, I have got 13.8 volt on the 8 volts on the scanner as well, and 13.8 here as well. So now we have got supply voltage, source voltage at the pump. So now I'm going to take the value of the control wire. Now I have got the control wire value at digital voltmeter, which is 0.252, and also I have got this value here as well. As you can see, it's which is 2.48, and also the on time, or the on time of the on time of the signal is so it's 44 millisecond. So between the two cursor, so the on time is 44 millisecond. So now I'm going to start the engine, and we are going to observe whether the on time or the full weight modulation is changing or not. So this is the live data that's showing. This is the live data showing. Okay, this is the sine wave of the control wire with the engine off, ignition on. So as you can see, the on time is very less compared to the off time. So if I freeze it, so and use the cursor, so as you can see, the height of the signal is 2.112, and the lowest side of the signal is 0.011. So okay, this is the live data. So the actual the signal as just can reach 2.5 volt, and here as you can see it's a 2 point maximum 2.499 and life is 0.249. So now I'm going to start the engine as the scope lead is connected to the control wire of the pump. And this is the sine wave with the engine idling. So it's 179.81 Hz. So this is the control wires signal to the coolant pump. With modulation. We also measure the current flow through the circuit, but no current flow is detected through the circuit. As you can see, no current is flowing. Very restricted. No current is flowing. So I now suspect, when I took the measurement this morning, now I suspect the pump, electric coolant pump. In spite of that, when I contacted the garage, they say this is genuine, but it's not at all. It's not genuine. I couldn't find any mark on that, on any brand like Audi mark on that, or any other brand which supplies the OEM parts. I couldn't find, and I suspect the pump is going to be faulty. So